This is a prototype of something that I'm making. It's 1,000 moving platforms all set up to run off of timelines, and they're all running simultaneously. You might be thinking, why use timelines for something like this? Unreal Engine already has movement components that make it very simple to make moving objects. Well, I needed my platforms to pause in between destinations, and Unreal Engine's movement components just didn't support that. And as simple and somewhat silly as needing platforms that pause is, it's exactly why I created this channel, to kind of fill those gaps in knowledge with unique solutions. And timelines are great for unique solutions. So what are they? Timelines are blueprint nodes that allow developers to quickly animate various attributes of objects in their world based on a timeline. Essentially, anytime I want to change something about an object over a set duration, I think of timelines. Part of their strength is that they can just be used with almost anything. If you need to move an object's location, if you need to change the scale of an object, if you need to change a color, they can even work with materials. Hopefully, this will make more sense after this example. So for this first example, I'm going to show you how I would use a timeline to adjust the scale of an object. I'm just using a project that I already had some stuff in. This should work in any project. So let's get started. First thing I'm going to do is just create a new level, give us a blank pane to work with. So file, new level, or control N is the keyboard shortcut. I'm going to select basic and hit create. Now we've got an empty map to work in. The first thing we need is an object to manipulate. So in the content drawer, I'm going to open that up, and wherever you want this actor to be, I'm going to use a blueprint class actor. So I'm going to right click and hit blueprint class, select actor. I'm just going to name it scaling actor. I'm going to double click and open it up. And the first thing that it opens into is a viewport. I'm going to add a cube. So this cube is going to be the object that I manipulate with my timeline. When you highlight the cube, you'll see in the details panel all these attributes about the cube show up. Nice thing about timelines is basically anything that we have access to in this details plane is pretty much editable with a timeline. Now I'm focused on scale, so we're going to use scale, but if you can grab a value and set it in a blueprint, you can pretty much use a timeline to manipulate it over time. Next, I'm going to head into the event graph, and then I'm going to right click and type add timeline. The first thing you'll see is this timeline node, and it's giving you the option to rename it. So I'm going to rename it scale, because that's what it does. It'll scale the actor. So like I said earlier, these timelines function off of literal timeline graphs. But before we look at the timeline graph, let's get familiar with these inputs and outputs. A timeline runs for a duration of time, and anytime you call play, it is going to play the timeline wherever it left off at. I don't usually use that one. The one I use the most is play from start. It'll play the timeline from beginning to end. Stop is something that you would call if the timeline was already running and you wanted it to pause. It'll stop the timeline wherever it's at. And then reverse is going to play the timeline backwards from whatever position it's already at. Again, that's one I don't use very often. I will use reverse from the end from time to time. It just plays the timeline backwards from end to beginning. And this set time is paired with this float input called new time that allows you to set a specific time in the timeline to play from. So those are your inputs. Your outputs, a little more interesting to me. This first one is update. I think of update like a tick, because for the duration that the timeline is running, that update pin is going to be constantly firing. Now, if I'm wrong about it being similar to a tick, if there's somebody out there that knows more than me, feel free to correct me in the comments and I will pin that comment. Next is finished. Finished only executes after the timeline has completed running. And then direction is an enum that tells you whether the timeline was playing forwards or backwards. So now we're going to double click on this timeline node, and you can see it opens up the timeline itself. The first thing I'm going to look at is this track. This allows you to add a number of tracks. The first one is a float track. This is just a float value that you can manipulate during the duration of the timeline. The second one is a vector track. Same thing as the first one, but with vectors. I've never used add event track, so I'm not going to talk about that. But there's also a color track. If you were trying to change the color of something like a material or light, you could use a color track to do that as well. And so for this example with scale, you know that scale is basically a vector, but I think it's a little bit easier to understand if we start with a float track. So I'm going to add a float track. The other thing, so after you click add float track, you'll see that it adds a track to the timeline and it wants you to name it. So I'm going to name it scale value. And if we click back into the event graph, you'll see that our timeline node has updated with an output named after the float track that we created, and it's going to output a float value. As you've probably already guessed, whatever the value of this float track is at a given time is what will be outputted from that pin. The other thing you may have noticed is this length value. This length represents the duration of the timeline. By default, it's set to 5 seconds. You can manipulate that to whatever value you need it to be. Now let's actually look at this float track. It should feel pretty familiar to control. Press and hold left click and you can drag around. Your mouse wheel is going to zoom it out. You'll notice that there's this gray box. This gray box represents the duration of the timeline. So since it's currently set to 5, the gray box starts at 0 and it stops at 5 seconds. Now, if we right click on the timeline graph, you'll see the option to add a key to the curve. I'm going to select that and we get a key added to the curve. This key has a time associated to it and a value at that time. So at time 0, we want our scale to be 1. And let's say we want this to grow 10 times in size over 5 seconds. So if we right click and add another key, we can set the time to 5 and the ending value should be 10. And I'm going to zoom out here so you can see it creates this nice linear line. If we wanted to, we can manipulate that by highlighting both keys. You just control and click, hold control and click each one to highlight them both. And if we right click on one of the nodes, it has this key interpolation menu. You can use this to change the way that we interpolate two values. Linear is just going to give you a consistent changing line. Auto is going to give you something that more eases in and eases out, as you can see. And then you can also use these blue bars to change the shape of the graph. Constant basically keeps the value the same until it's time to change. That could be useful for something like flickering lights, where you want the value to be 0 and then suddenly 1. But I'm going to leave it at linear for now. So now that you've seen the inside of a timeline, let's take a step back into the event graph. The next question we got to ask ourselves is, what are we trying to update? Well, we're trying to update the cube scale. So I'm going to drag cube in, and from cube, I'm going to type set scale. And I'm going to set world scale 3D. And as you can see, this node takes in a vector, but we're outputting a float. Now, we want our scale to remain consistent across all axes. So what I'm going to do is right click on new scale and split the struct pin. And I'm going to connect scalar value to each one of those struct pins. So what that's going to do is update the X, Y, and Z scale values using whatever value is being outputted by that float track. Next, we need to connect update to that so it actually does update. And that's all we really need. We just need a way to call it. So off of begin play, I'm just gonna delay for 1 second just to make sure I can see it in the viewport before it starts doing stuff. And then I'm going to connect completed to play from start. Next, we need to add this actor to our world. So I'm gonna compile, save, and minimize this window. And in our world, I'm gonna open up the content drawer. I'm gonna drag in the scaling actor where we can see him. Now, when I hit play, it should delay for 1 second. Then over the course of 5 seconds, increase the scale value of the cube. So here we go. As you can see, it worked exactly as expected. So that's how you'd use a timeline to manipulate the scale of any object. The important thing to remember is whatever attributes we have access to, we can use a timeline to manipulate them. Let me show you how to do this same operation with a vector track instead of a float track. So we're going to come back into our timeline, and I'm going to get rid of this float track by right clicking and hitting delete. And I'm going to add a vector track. And the main difference that you'll notice is instead of a single line, there's now 3 lines that we have to update. So I'm going to name this track scale value vector. And so we're going to do the exact same thing. The reason why it's a little different is because we have to manage all 3 X, Y, and Z values on this timeline. So I'm going to right click and I'm going to add a key to all curves. And I'm going to set the time to 0 and the value to 1. And we got to do this for each vector value. So for the Y, time 0, value 1. And then for the Z, time 0, value 1. Then we need to add a key value pair for what the value should be at 5 seconds. And we're going to do that same thing 3 times. So at time 5, value should be 10. We'll highlight X track. At time 5, value should be 10. And we'll highlight the Y track. At time 5, value should be 10. And if we come back to our event graph, let me remove. So the reason why this is now red is because I deleted the scalar value. It doesn't exist anymore. Let me break these links. And then let me recombine this struct pin. Now we can just drag the scalar vector into the new scale. And when we hit play, it should run the exact same way. So here we are, I'm gonna hit play. And as you can see, it's functioning the exact same way. So now that you know how to use a float track and a vector track, I'm gonna show you how to make an object move smoothly using a timeline. Come back into our scaling actor blueprint, and we look at our timeline node. We can go ahead and delete all of this actually. So we're not gonna use any of it to make this object move. So first thing I'm gonna do is right click and type add timeline. And then I'm going to title it movement duration. And this is a little unique because we don't actually need to add any output pins to make this happen. All we need to do is update the actor's location smoothly over time. So out of update, I'm gonna type set actor location. And we need a new location. So I'm gonna create a variable. I'm gonna call this ending location. And it's gonna be a vector. Hit compile. And I want to base our ending location off of our starting location. So off of event begin play, I am going to drag out set ending location. And off of, then I'm gonna right click and say get actor location. And off of get actor location, let's do a little bit of vector math. Do an addition. And for the X and Y values, I'm gonna increase it by 1000, but we'll leave Z value at 0. And then we'll connect that to ending location. So now we have our new ending location. We need to make sure we move there smoothly. So if we were to just put in the destination location, the object would practically teleport there. So in order to make smooth movement, we need to use the VInterp node. So off of new location, I'm going to type VInterpTo. And this VInterpTo node attempts to reach the desired target from its current position, and it attempts to give it a nice smooth feeling. So the key word here is tries. There's no guarantee, especially if you don't give it enough time to make it to where it needs to go, it won't always make it there. So current is just going to be the actor's current location. So we'll get actor location. And target is going to be our ending location. I'm going to hold control and drag ending location into the blueprint. Delta time, I believe it's the time since the last tick. Now, I don't really comprehend what that means, but I just know that I use get world delta seconds, and for whatever reason it works well. And the interp speed is the speed that you want the object to move at. The smaller the number, the slower it goes. Of course, unless it's 0, then it'll just teleport there. So I'm going to set this to 5 by default. The last thing we need is a way to call this. So I'm just going to connect. Well, first I'm going to delay off of begin play for 1 second just to make sure we can see it in the viewport. And then I'm going to connect that to play from start. Now, like I said, you might notice that we didn't actually open up the timeline at all. If you're using a timeline to move an object, you don't actually need to assign a vector track to be a new world location. We just need it to attempt to perform this smooth movement for a set duration of time. So let's hit play and see what happens. As you can see, it moves pretty slowly from one point to another, just as we'd expect. Now, the really cool thing about timelines is you can add as many tracks to a timeline as you need to. So instead of just moving this object from one point to another, we could also scale it while it's moving. So I'm going to open up this movement duration timeline. I'm going to add a float track. I'm going to do this the exact same way I did the first time. Add a key at time 0. We want our scale to be 1. But then by the time we get to 5, we want our scale to be 10. So time 5, the value should be 10. We come back to the event graph, and off of set actor location, Well, first let's grab cube, and off of set actor location, we're going to set the scale of the cube. Set world scale 3D. And whoops, I just realized I forgot to name our new graph. I'm going to right click, rename it scale value. Then I'm going to split the struct pin and connect the floats from scale value to each one of those. When we hit play, the object should move and scale at the same time. So here we go. As you can see, it moved and grew at the same time. The reason why it continued to grow was because it got to where it was trying to go way faster than I anticipated. It didn't even use all 5 seconds. One way we can adjust that is in this VInterpTo, we can reduce the speed. Let's say we reduce the speed to 1. So it should move very slowly across the screen now as it grows in size. Let's hit play. So as you can see, we're moving much more slowly and growing at the same time. All right, y'all, that's how I use timelines. Anytime there's an object that I need to manipulate over a set period of time, I think about timelines. Timelines are just one of those nice tools to have in your tool belt to help you come up with unique solutions as you need them. The last thing you got to do to make all this stuff work is just hit that like button on your way out. Peace.